It's time for Pure Performance.
Get your stopwatches ready. It's time for Pure Performance with Andy Grabner and Brian Wilson.
Hello, everybody, and welcome to another episode of Pure Performance. My name is Brian Wilson, and as always, my wonderful co-host, Andy Grabner. How are you doing today, Andy?
Brian, hello. Very good. Sunshine outside and not as high in temperatures as I know you told me earlier on your end. But at least the rain is gone for one day, even though we've been hoping for rain because we had a too dry period. And now I think the farmers are happy again. Now it's time for some sun and some warmth.
You know, it's funny. I do a lot with music. I really listen to music a lot. And in that, I've been noticing a lot more lately when people talk, their words trigger songs in my head. And I think there are about 3 or 4 that went off in my head as you were just saying that. So that was just really disturbing to me because I don't know what's wrong with me. So fortunately for everybody listening, I'm not going to start singing any of them. I'll leave the singing to you, Andy, because I'm sure you have a better singing voice than I'm glad your weather's fine. I was telling you before we started, we have this whole Miller moth problem in Denver, and it's really, really bad this year. It's horrible. So anybody who knows about these moths, it's really, really, really rough right now because not only are we stuck with kind of being pseudo quarantined and all, but now you can't even turn on your lights at night because they all come in your house. So real fun times right now, but it'll pass. This too shall pass, as we say. But we have better things going on.
Well,
right,
and maybe also better weather and no moth problems on wherever Steve is from.
Yes, Steve who?
Steve who? Steve.
Steve. We have Steve Jobs on the show today.
Nah, I don't think so.
I can't hear it.
So Steve,
bringing the Joe from beyond.
Yeah. So Steve McGhee, hopefully I pronounced this correctly.
Yep.
Cloud Solutions Architect. At least that's what I read from. I'm looking at just one of your blogs on blameless.com. And Steve, you can probably just do a better job in explaining telling the world, or at least the listeners, who you are, where you are from, and also how the weather is and where you're from right now.
Yes, I'm Steve McGhee. You got it right. First try. Congratulations. There's a secret little H in my name, which is completely silent. You can just ignore it. So I live in San Luis Obispo, California, which is also known as SLO or SLO. And I'm an SRE. And I find that hilarious that I'm an SRE that lives in SLO. If your listeners get that joke, I think it's great.
I actually visited that place in 6th grade.
Yeah, there's a mission right downtown. I'm about 200 feet from the mission right now, actually, sitting in my car. And
that's pretty awesome.
It's a beautiful day in Central California. My background is I worked for Google for 11 or 12 years. I was an SRE for about 10 of those. I worked on a bunch of stuff, so like Android and Play and Compute Engine and YouTube and all over the place. And then I left. I came here to beautiful Central California to work for a company called MindBody Online, which is it's like an app that helps you find gyms and salons and haircuts, studios and stuff like that. And I helped them do the cloud thing. So I became like a cloud customer. And then I moved back to Google to basically help other customers, other companies do exactly that. Figure out what this whole cloud thing is and how to use it properly. And my sort of specific angle on that is how to develop reliable systems on public clouds. So how to do SRE on the cloud basically is kind of my goal. So I help a bunch of companies do that all day, and it's pretty fun.
Yeah. So
that's awesome.
That's pretty cool. So you said you were at Google for 11 years before you did the other gig, and now you're back. So you've been doing SRE for what, 15 years?
Yeah. So I was, when I first started at Google, I worked in the partner team, but I was working on reliability stuff then. So there wasn't SRE back then, but looking back, it was awfully SRE shaped. So I developed a monitoring system that let us understand when other companies weren't showing our ads or search results properly. So one of my favorite stories from that is when MySpace, if you remember MySpace, it was a big deal at the time. They showed ads, Google ads, and we would find out when MySpace was down before they would. And I remember calling their knock saying, "Hey, your site is down." And they said, "No, it's not." I said, "Yes, it is." And they went, "Hang on a second." And then they were, "Oh, you're right. Hang on." And they would go reboot something. So we were kind of their pager.
Because you saw a drop, obviously, of requests coming in from them. Yeah.
Yeah. Because I mean, if our ads weren't showing on their site, we were losing money and they were losing money. So we, it was like our responsibility to make sure that they kept their stuff running, which was kind of a funny way of doing reliability. I wouldn't recommend doing it that way ever again, but it worked at the time.
But that's a great motivation if you are obviously not only a cloud vendor, but you're also one of the largest ad vendors in the world, right? And you want your ads to be shown on websites that run on your cloud. You better make sure that these sites are reliable. And
one thing that has always been interesting. We didn't call Tom. No, I considered like, hey, is this Tom? But no, it was the operations center. But one thing that we've always or the way I've tried to think about this kind of stuff at Google is that like, forever Google was an advertising company, but like they also made like Chrome, and like what's the deal there? Like, why would an advertising company make a web browser? But the idea was simply like, if you make the whole internet better and more reliable, people are going to use it more to go, do whatever it is they want to do on the internet. And that's just going to naturally drive up basically ad clicks, right? This background radiation of a way of making money on the internet. So like, I try to think that like in GCP, like the background radiation is not ad clicks, but it's, VM hours essentially. And so if we make it easier for people to run businesses successfully on cloud, we're just going to drive up more of that background radiation, right? We're going to have more VM hours happen, like as a consequence of making the system better. And like, if you can have an e-commerce business on the cloud that is more successful than it would have been on-prem, it's better for you, but it's also better for the cloud, and it's better for your customers, and it's like it's a win-win-win kind of situation. So that's the way I try to take it.
Very cool.
It's interesting you mentioned that, because I don't want to mention the competition by name, but there's this monolithic, very old school company that's also a big competitor in the cloud. We'll leave it at that. But their model used to always be operating systems, and as you said, the idea is if you make things easy and usable, people will use it, and you can put new revenue models. So I think you nailed it on that. You really just nailed it with what you said there in terms of, make everything easy and people can use it without thinking, and the money will flow in. In fact, we see that all the time, right, Andy, where people just spin things up, don't even realize they're still running, and like, oh, that's right, I have a VM running. Oops, because it's too easy till the finance team comes screaming at you.
Yeah, we don't want that to happen either, too, because then they get mad and they the pendulum swings the other way, and no one likes that.
Right.
So making sure that type of thing doesn't happen too is good.
And Google Cloud actually has a great modeling to say you can save money on this VM by reducing size because you're not using it. And I think that was really, really innovative of you all to do.
Yeah, that was a fun one. I was on the Compute Engine SRE team when that came out. That came out of the Poland office, and it was just one person in the Poland office who just kind of had this idea of, we can just show these little pop-ups and say, you're not really using this VM. What if you did it something else? And the original idea was to automatically change it and be like all dynamic. And we said, well, what if we just pop up like a little sticky note that says, hey? And so we did that. And just that was a big deal. So people loved it. They still do.
Hey, Steve, so with all your experience on SREs, even though you live in slow, but you are an SRE, reading a blog, I mean, there's a couple of things you put out there, but what I found interesting is your approach of how can people get started with SREs by starting with something they should do hopefully anyway in case something is not reliable, which is postmortems. And it would be great from your perspective, because we've been, Brian, right? I think in the last couple of episodes, we focused a lot on SLIs and SLOs and SRE. We had a couple of your colleagues on and some other folks talking about site reliability engineering. And the question then always comes up, okay, but how do we get started? What's a good model? Because we're not born in the cloud. We're not cloud native yet. I mean, give me something, right? And would be interesting to hear from you, because I believe you did a great job in the blog explaining the approach. And so I want to hear from you. How do people get started? What do you advise?
Thanks. Yeah, I'm glad you liked that article. That was kind of a partnership with Blameless. So this was while I was at MindBody, actually, and it's entirely just out of the experience at MindBody. So this wasn't a Google like sanctioned official way to do anything. This was just like my experience at the time. It happened to be published later once I was back at Google, but it's actually, I believe the interview happened while I was unemployed, actually, between the two things. But anyway, but the idea was essentially that, like, outages happen everywhere and everyone is always, dealing with them. And the idea of postmortems are pretty understandable. Like, you might call them retrospectives or learnings, or, there's all kinds of words for them. In Google SRE, we called them postmortems for a long time, which is maybe a little bit dark, but I think the idea comes across reasonably well. But I found that in this one company that I was working for, MindBody, they were doing something that was pretty close to postmortems, but they were doing it inconsistently, and they were, kind of everyone would have their own way of writing up the document, and then they wouldn't necessarily always follow through, and some people would, and some people would kind of forget about it, and blah, blah, blah. So basically, I just kind of introduced the idea of, well, we're already doing something like this. Why don't we just add a little more rigor to it? So I introduced like a postmortem template, which was really, really simple. And it's, it's only like 1 page long, and it's a couple headings, just sort of like to give you some sense of what to write, because I found a lot of people would just ask me, like, hey, you wrote this postmortem and it looked pretty good. Like, how do I do that? And I just gave them, a halfway filled in document, and that it helped a lot. So being able to just start with something you're already doing and just improving it slightly is a really good way to start improving a practice across the board. The other thing you can do is if you already have seen good postmortems in practice, like I had at Google for 10 years or so, I would just write postmortems for incidents that I was kind of observing, and I would say, hey, I wasn't really involved in the outage, but like, I'd like to write it down or help you write it down for you. So I did write a few postmortems for incidents that I was just kind of like sitting on the sidelines of. And then I made sure that they were, more well written, and that at least they were complete. But the most important thing that I've kind of found, or like the most helpful thing that, like, in terms of outcomes from doing this, was making sure that you write at least 3 types of, kind of, I would call them bugs, but, just kind of tickets, maybe, action items. And those would be, detection. How can we detect this better or sooner or with more precision? There's prevention. How can we prevent this from ever happening again? And then there's mitigation. So how can we, if this does happen again, how can we survive it better? And so if you can at least write one of each of these, you're in good shape. Generally, there's more of some than another, and often the prevention one is like very difficult, but you should still be able to write it down and like put it into like a persistent ticket queue, or bug filing system of some kind. I have heard from some companies they would do this, and they just kind of say, well, but we don't have a bug filing system or like a ticket queue that's like this. And I say, well, okay, this is a good reason to get one. Like, this is sometimes just doing this process sort of exposes other capabilities that are missing as well. So it just starts to kick off a few things.
That excuse is like a kid saying, I can't eat my peas because I don't have a spoon. Oh, here's a spoon.
There you go. Exactly. Yeah.
I think it's interesting too, because what you're saying about having those plans and having that edict in there. I haven't worked on I've been in sales engineering since 2011, but before that I was in the performance side, and we started doing some postmortems, as we were actually calling them back then. But it was just a meeting where we'd all get in a room and discuss what happened. There was no organization, there was no focus. It was just a bunch of people, kind of partially blame game, but I think they called it a postmortem because we were trying to figure out what happened. But It was very, very loose, no focus, no goals. And I think the key, as you're saying there, is to have some sort of goal, even if it's, something as simple as that. And I think that's missing from a lot.
The other thing that's important to do is, like, once you have the basics of oh, we should be writing these down in a consistent way, and having like a template that at least has all of the fields that you care about, and you start getting some practice writing these. The next step in this is then to have a review forum almost, or like a meeting. So the suggestion that I have, I hate meetings, but like the suggestion I tend to put out there is just put something that is regular cadence, like once a week, once a month, whatever it is that you think makes sense for, depending on how many outages you have, I guess. And say this is, it's every Thursday at 10 o'clock, we're going to have the Post-Mortem review session. And there is a standing agenda document. And all it is there are, it's a 1 hour meeting and there's 3 20-minute slots, and you just sign up for a slot and that's it. So if there's already 3 scheduled, then just wait for next week. But what you do is you show up with your postmortem that you wrote. You send it in ahead of time, and the sort of curators of the meeting will, read it and kind of get a sense of what happened. And then during that 20 minutes, all they do is you just kind of have a discussion on either the document itself, where they'll say, well, you forgot to, add these types of outages, or, resolutions, or like, we don't really understand the impact. They'll sort of help you write a better document. But even better is they'll give you an opportunity to sort of explain what happened and what you think the resolution is, and, what the prevention steps and all these are, to like a semi third party who has almost no interest in the actual outcome, aside from making sure that it's a good learning experience for everyone and that the system becomes better over time. So this sort of forum is, it's still employees within your same organization, but, they're not the authors of the system that broke, and they're not the people who got paged during the incident. No, they're semi uninterested. They can be pretty neutral parties, I guess. Having a forum like that is super, super helpful for driving up the quality of these postmortems, as well as making sure that the outcomes like make sense. They're not just, super inside baseball and like are super, super deep. Like they'll help you kind of focus on the things that will actually help the company. Mm-hmm. That's another kind of step you can take.
Yeah, one quick question. So I guess maybe that's part of that forum or that outside body. But if you start writing postmortems, with every problem that you see, and if multiple people start writing it, how do you make sure that you're just not creating a large list of things that in the end nobody really not cares about, but at least, right? How can you make sure that you are catching duplicates? How can you actually then, hey, this happened before, did it happen before?
Yeah.
Are there any good systems for that, or is this part of, I don't know, is part of the best practice, part of the body you put in? Yeah.
There's a couple problems with this that are really easy to fall into, and you have to be careful of. One is I don't want to spend that much time writing documents, and like how much time I don't want to make the perfect document every single time. Like we had an outage, like what's the big deal? Like why do I have to write? People feel like they're being punished because they have to like write this big document. And that is definitely not the case. That's not the point you're making, but that's like a similar point. Mm-hmm. Having a good, template helps a lot here, in that you can say like, all you need to do is fill in these like 10 fields and you can be done in 10 minutes. Like, and at the simplest case, but then further along is like, if it was more complicated, sure, you should spend more time and explain it a little bit more. But what you're asking about is more like, if the same event keeps happening over and over again, like, are we catching it? Or how do we know that the outcomes that or the resolutions or bugs that we're filing aren't just being ignored? How do we prioritize them, or how do we make sure that they're going into the right bucket? And really what we're doing here now is we've moved into the realm of operations into software engineering, right? So we're raising essentially feature requests or actual, bugs in our feature tracking system or our bug tracking system. So the real question is like, is your company good at prioritizing work? And is your company able to take, bugs from customers or from product managers or, from internal engineering or QA? How do you do that process today? Like, how do you determine if something is a duplicate bug or overlapping or something like that? And you just use the exact same system. So really all we're talking about here is just another form of defect. So this is just generic defect tracking. And again, this is the spoon problem, right? So if you don't have a good way of tracking defects and you try to do the system, it's not going to work. And it's not because this process is broken. It's because you need a good defect tracking system.
Now, what I don't mean to, hopefully this isn't jumping ahead at all. But I see I imagine two outcomes from these postmortems. Number one are things like defects. Something broke because it was coded wrong, right? Or something, something in that system. But another reason why there could have been an outage is because some things weren't monitored either at all or properly, which requires not a fix in the code, but in the fix in your monitoring coverage or what might be acceptable limits, jumping into a little bit into the SRE side. What is an acceptable limit of, number of database calls that we can handle, and we weren't monitoring those, and blah, blah, blah. So that thing goes into fixing your monitoring. And, is that something that you would handle through, like, let's open a ticket to change the way we monitor so that we can avoid doubles and all that too, or?
Totally. I don't distinguish between the monitoring and the software, because it turns out monitoring is made out of software. And what you really care about is the entire system, right? Like, your CEO doesn't care if it was the Ruby that broke or the Prometheus rule that doesn't exist. Like, he wants to know why the system itself isn't working.
Okay.
So the idea is, like, don't treat, configuration and operations and monitoring as like something that isn't software, because it is software. Like, it should be tracked as in a similar kind of way. There's the phrase configuration as code, or configuration is code. I'm a firm believer in that. Even better is when you have code that outputs configuration that goes into other code. Like, there's code everywhere. So, these are all just forms of defects. And I think trying to introduce a different process for operations is just going to be confusing. So if you have like a consistent way of handling defects through your company, whether you're writing YAML or Java, I think it's super important that you treat all these, system defects similarly. That way you can prioritize work in a consistent way.
Right. That's really interesting. Never thought of, so yeah, everything's a defect, just gets categorized to different teams.
Yep, totally. And then, because you also find, like, if you're changing a system, often you're introducing a new piece of functionality into, like, the Java, for example. And then, you say, well, actually, at the same time, we want to introduce some monitoring. So you want to be able to introduce these things in a consistent way and say, here's the new feature set, and here's the monitoring that goes with it. And, like, if you have to span multiple systems to do this, people are going to be less likely to do it just because it's annoying, but also it's going to be a lot harder to enforce or to track that this is happening. So if you have sort of one system for doing both things, you can say, here's the new feature, and in the same, change set or whatever the system is, that you're using calls it, here are also the tests that go with it, and here are the monitoring rules that go with it, and here's the, on-call team alias who should be in charge of it. And it's all in one, package suite. So that way, when something goes down, you can track it back to that one set of changes and say, we introduced this feature, but we forgot to add, some bit of observability or something like that.
And I think another great advantage of that is you'll get to test your monitoring or your system change early on to make sure that, number one, it works.
Right.
Number two, that it doesn't introduce any other kind of problem, right? If you suddenly say, hey, we're going to monitor heavily on something that's, that could cause an issue. But if you put that in early in the system, that's part of what Andy and I talk about, the whole idea of shifting left for not only your code changes, but I shouldn't say Andy and I, everyone talks about it, right? But shifting, but also, your monitoring is code, your system, your code is code, your deployment is code. It gets tested throughout the entire cycle before you get to production to make sure that it's doing what it's supposed to do. It's giving you the results or the information that you need to act upon, and you're not just guessing and throwing in production, and then the defect happens again because you picked the wrong metric to look at.
Yeah. So one thing that you I think you referred to before, it's kind of around the cause tree thing a little bit, but like when you do have, this is from the article that you guys sent me about Dynatrace's like auto healing capabilities and things like that. I thought that was a neat article. One thing that you referred to was about sort of automated remediations. And I think like I said, kind of in the email chain, like I'm really leery about that concept of automated remediation because it sounds too good to be true because like it is. Like you can't rely on it, to work all the time for all the things. But one thing that you can do, which I think is kind of what your system does and is good at, or at least the one that was described in that blog post. I would describe them as short-term remediations. So like if you have an on-call team who is in one time zone and something goes off in the middle of the night, it's a total hassle to wake someone up to do something dumb, right? To like increase, memory or like restart a process or something like that. So being able to distinguish like an outage, when you have an outage, being able to distinguish a remediation from like a quote real fix, like a prevention mechanism or like an actual, bug, fix is super, super important. So, I think automated remediation when it comes to these short-term fixes is great. It's super, helpful. It helps people like sleep at night and, gives you signal into the system of what's kind of going wrong. And maybe it's not even middle of the night things. Sometimes it's just like during, high load or something like that. But the really, really important thing that doesn't happen sometimes is people think that when the remediation happens, like, oh, we have a remediation. Great. We're done. Like, no way. Like you need to have basically like a due date on these things. Like this is a short-term fix and it will actually expire in 2 weeks. This remediation will no longer work 2 weeks from now. So, software engineering, you have 2 weeks to fix this properly. So in Google, we had some things like this where if you put something, one of these short-term fixes in place, it has a required expiration field and you can't put, infinity in that field. There was a maximum of, 2 weeks or something like that. So, I think that's super important to emphasize that these short-term fixes need to be like enforced by not just, good intentions, but also like the automation of the system itself to say like, required field is when does this remediation get lifted? So if you can do that, I think it's a really good incentive to actually fixing it properly, which is the only really righteous path forward.
Yeah. It also, Brian, this reminds me a little bit, I think the first episode we had with Goranka Biedov from Facebook when she was still working at Facebook, and she talked about the fix-it ticket. So she basically said it's allowed to deploy something not perfect into production, but then you have like a due date until you have to optimize it in a way so that it's truly fit for production. And I thought that was also interesting content. Also, thanks for reading the blog. And I totally agree with you. These are, English is not my first language. So whether you call it remediation or maybe mitigations, I think what you're talking is probably mitigating the impact of a problem long enough so that people get some time to truly look at the problem, find its root cause, and then fix it. It's like, right, one mitigation would be we just restart your application server every time it runs at 80% memory because we have a memory leak, but it's not a solution to the real problem. Or like, I don't know, some other, as you said earlier, scaling up in case of peak load, but maybe we need to come up with a different solution to deal with this. Maybe we need to optimize the system to be able to scale better or something like that. Yeah, I agree with you.
Mm-hmm.
Yeah, I think it's really interesting because I can see people abusing that. Right? It's when you mention it, when you talk about it that way, Steve. If one thing I think a lot of people encourage, and we encourage, it's great to automate your playbooks for production outages. Whatever your standard operating procedures are, automate that and get things back up and running, and that then could be triggered based on metrics coming out of your observability tool, aka Dynatrace. But I think you bring up a good point that people, especially if you have it really well locked down on the automation side, that people might just rely on that and keep on letting these things fix and not fix it. So it'd be really awesome to see if these tools like that do the remediation, like Ansible Tower or others, adopt some sort of expiration, or if there's a way to put that into those playbooks, so that where it does apply, people can leverage that. Is that I could just see that being become a real liability.
Yeah, because
just these scripts running all the time, band-aiding all, plugging all the leaks.
Yeah, the problem is that it looks like an asset and it's actually a risk. So when you have a dynamic system, especially a dynamic distributed system, like when you get out of monolith land and you have like this system that is always slightly broken and always slightly changing, every Band-Aid that you apply is like very specially shaped for the problem at hand during that moment in time. Mm-hmm. And so when anything changes, which it will, undoubtedly, that Band-Aid is going to become a liability, and you're not even going to remember that it's there. So being able to sort of like keep a running tally of how many Band-Aids are, in production at any given time, and making sure that they get burned away with time, is super critical, 100%. So, I mean, this is not hard stuff in terms of like reporting and, coming up with goals and like being able to keep track of how many there are out there and when they expire, and like telling your team, okay, let's try to, get next week, let's try to get 2 or 3 of these down. And, you just got to know that that's the idea, because otherwise the good intention is like, oh, we have a mitigation system in place. Let's use the heck out of it. Let's use it so much, when really you kind of want to use it as little as possible.
Mm-hmm. Mm-hmm. Hey, got a question for you. So you mentioned, monitoring being, obviously it has to be part of the, let's say, software delivery, because monitoring is just software as well. And that whoever, builds it and configures it in obviously needs to take care of it. Do you have a strategy on testing monitoring? Because, on the one side, we write unit tests and functional tests to test the functionality of the software. Is there anything kind of in the software engineering practice that also includes testing if the monitoring data itself is actually what we expect? And then going further, is there anything that you have as best practices on how do we test the remediation? Because it would be kind of risky to say, well, we have remediation in place in production, but we've never been able to test it, so we just assume it works. So kind of these two things. Is there anything, that kind of extends test-driven development to test-driven monitoring? I'm not sure, I don't think this is the right term, but I think you get the idea, right? So testing the monitoring and testing the remediation as part of the pipeline.
So inside of Google, there was a system, I'm sure it still exists too, but there was a system that was exactly for this. It was like a monitoring rule test framework. And it worked fine. Like you give it input data of, the counter goes from 0 to 1 to 2 to 3. And then, over the course of time, like if it exceeds this rate, then fire this alert. And it worked. It was notoriously hard to use, but people did it. However, the idea of doing test-driven monitoring sort of flies in the face of the kind of slightly newer, at least SRE type of methodology, which is that you don't actually want to focus on every possible cause, but instead you want to focus on symptoms. Mm-hmm. So kind of the false goal is to be able to enumerate every possible cause and then define an alert for it, and then maybe write a test to make sure that the alerts work, or that the monitoring exists for each possible cause, and then proceed from there, which is totally intractable, especially again for a distributed system which is constantly changing, because you're always moving those causes. You're introducing new causes and getting rid of old ones. And so you're just going to be on this treadmill of adding and removing alerts, as well as those tests, which sort of enforce the validity of those alerts. So we found this to be the case, many years ago, that this was just like this impossible task. And so it took a long time to realize that what was going on. But essentially, we realized this is kind of what we would call praying to the wrong god. So what you do instead is look at symptoms. This is where SLOs come out, right? So this is looking at what the end user sees, if it's, fast enough and correct enough, and, there's, it's available enough, and all these things like that. So this is kind of a rehash of probably things you've already talked about, but like, just because you add SLOs and availability and latency alerts doesn't mean you get rid of all the other monitoring. It just means that you don't react to it directly. So the way that this is actually a pretty good parlay into the cause tree we were talking about. But like, if you think about, when an SLO violation occurs, it's, something got slow, or something became, slightly unavailable, like it started issuing errors, more errors than we like. That's like the top of a tree. And I mean like a, computer science type of tree, right? Mm-hmm. And so like there's this huge graph of nodes that may have caused it. Why did it get slow? Well, I don't know. Was it the load balancer? Was it, the container ran out of memory? Like there's a million things that could have possibly caused it. And this is exactly the postmortem, or actually really the incident response process. Like, being able to do this in real time is great practice for coming up with, how to better sort of develop your alerting, system. Essentially what you want to do is you want to be alerted by the root of the tree, which is, the system is slow or having errors. And you want to be able to run down this potentially huge, cause tree. Mm-hmm. And you want to be able to prune that tree, right? You want to say, well, this entire right branch of potential causes is not the case. We've ruled that out. So you don't have to go down any of this. And then you go down the tree a little bit further and perform some tests and say, well, we've ruled out these branches as well. So this is, if you're into computer science and stuff, about, tree branch pruning. Pretty quickly, you've reduced your search space to something totally, achievable. And you can actually then go to each of the leaves and test them individually and say, was it this? Was it this? Was it this? Nope. No. Okay. There's the one. Okay. It's finally, we figured it out. We found the cause, and it might be a novel cause. It might be one you've never even considered before. So this is what I mean when I talk about pruning the cause tree. I used to call it pruning the blame tree, but I think the word blame has personal consequences, which is not what I mean. I just mean like what part of the system is the cause or is to blame. So being able to do this generally isn't the case that, you have perfect monitoring, rules in place that you've written tests for. What it is, I think, and really is that you have a fully deployed, fully usable, like observability suite, which isn't something that you have to keep writing new rules for. So it's something that you're able to introduce new code, which has been, instrumented by the developers of the code, saying, yeah, these are important, counters, these are important distributions. And then you just sort of step back. And then when the moment comes that you need to look something up in the observability suite, like what is the distribution of this, bucket, over time, you can just call for it from the observability suite. I think that's the kind of the righteous path forward as well. So it sounds weird, but, I think spending a lot of time on making the perfect alerts and the perfect dashboard is kind of the old and busted way. Mm-hmm. And what you really want is a observability suite that allows you to make, sort of just in time dashboards, for interrogating the system, based on, symptoms, based on SLO alerts. Yeah. If you can build that, I think you're miles ahead. I think you're in good shape.
Yeah. I mean, you are, it sounds like, it's music to our ears, what you're saying, because basically, we,
good.
From our perspective, we work for Dynatrace. So this is exactly the approach that we are taking, that where it matters most, and that's either the end user, because we also include end user monitoring data in our alerting on the top, or service level, right? Your SLOs. And then in case we see an anomaly, and, we do, I think that's what you guys are doing as well, and others, right? We have the combination of, you have, let's say, hard-coded SLOs, let's say a certain threshold, or we just baseline and basically learn from the past, and then alert on anomalies. And then we basically walk our dependency tree into all directions, because we are combining distributed tracing with full stack monitoring information. And then we basically walk that tree and figure out in which path do we really have the problem, and then we can leave out the other things. And then we can also see, okay, how did this historically, where did it start, and what's the true root cause? So that's it's good to hear from somebody like you that this is, obviously really solves the problem. And we've known this from our customers that they also like it. But I also have to say, a lot of people, that have been living in the monitoring space for too long and are very proud of their beautiful dashboards, a lot of them still start with, okay, what can I put on the dashboard so that I can, I don't know, just, feel like I'm under control, if there's a problem. Right?
So this is a great example of, really good intentions, but not really focusing on the right problem. I actually just had a customer the other day who was asking me, they were performing a load test, and they were using a system that we have at Google. It's a managed Redis, basically.
Mm-hmm.
And they were saying, the CPU is too high. Why? And I said, oh, okay, well, that's weird. Let me check it out. And they said, why is the CPU pegged? And I kind of went, well, I don't know. What are you doing with it, kind of thing? And basically I said, well, what's the problem? He said, well, the problem is the CPU is too high. I said, well, that's not a problem. That means that you're using your computers well. Like you're using exactly as much of the computer as you need. What's the actual problem? They said, well, there's nothing. We're just worried. And I understand that. Like that's there's plenty of good intentions, because they've seen many times in the past where elevated CPU it's a leading indicator of an actual problem later. And that's no fun. However, high CPU doesn't really mean anything by itself until you actually have, a user facing indicator that actually says, yes, this is a problem.
Yeah.
So,
yeah. Again, Brian and I, we come from a performance engineering background, and, one of the aspects of performance engineering is obviously performance optimization. So if you see something like this, you may wonder, is this normal? And if not, how can we optimize it? But then you have to compare it either to historical data. So was it always at 100% CPU, or did it just jump from 80 to 100%? Still not having an impact to the end user, but still, why did it jump from 80 to 100? Because of the last build, right? So these are obviously fair questions, but I understand what you're saying, right? People too often are just freaking out on, there's a metric that looks strange to me, so let's ring the alarm bells, without knowing if it's really impacting the bottom line, which is, are we meeting our SLOs? I think that's what it is in the end, right?
Right. And again, it's always based in good intentions.
Yeah.
Sometimes it's due to, past experiences that, they've seen this type of pattern before. Sometimes, sadly, it's just kind of cargo culting. They've heard that this is bad, so we should totally change it.
Mm-hmm.
But really the great thing about having something like SLOs in place is that no matter what their intentions are, or what their, maybe misunderstandings are, is that you can point back to this one number and say, like, is this number okay? And they'll go, oh yeah, that number's okay. And then you can say, okay, so, stand down, everyone take a deep breath. Mm-hmm. We're good. And so it's really a matter of practice.
Yeah.
So if people have these habits, you kind of have to give them a way out. You can't just tell them to stop.
Yeah.
You have to give them something that's better.
Yeah. Hey,
let me ask a question there, though, because it almost sounds like we're talking two extremes, and I'm wondering about the middle ground here, right? Obviously, if you're just pointing out CPU's higher, even if they're, CPU's higher, you don't always want to jump on that. But if you're taking an extreme end user view of it and say, all right, CPU's higher, but there's no impact to the end user, there is, there's the potential to be glossing over problems that are going to arise. Like if the CPU went from 20% normally at the same load to 80% suddenly with the new code release, but still there's no impact to the end user, you've just pushed your system to a place much further than it was, which could be bringing it closer to the edge. That means if you have suddenly an increase in... So what is that middle ground, and how do you define that? Because in the last discussion we had about SLOs and SLIs, a lot of it came down to, again, what's the impact on the end user, and defining your performance or your reliability from that perspective. But I feel like there's been this unspoken whitewashing of what the system's doing underneath.
Yeah, so you have to have this first discussion that we just had at first, and then you can get to exactly this point, which is, so what happens, like a great example of this is quota issues, right? So you can be humming along just fine, and then you're going to hit some quota somewhere that's, 200 somethings per second, whatever it is. And it's like somewhat arbitrary. It's just whatever the quota was, right? And then your system's just going to fall off a cliff, right? And then you're going to have this big fire drill, and you're going to freak out, and you're going to say, why didn't we know about this? How come we didn't have a leading indicator? Which is kind of what you're getting at, is some of these non-SLO metrics could be used as leading indicators. And so we should pay attention to them, right? So my response to that is like, that's true. However, there's always going to be leading indicators that you're not watching, and there's always going to be indicators that occasionally lead, right? So do you want to have a lot of false positives and false negatives? Probably not.
Mm-hmm.
So the solution to this is not easy, but the solution to this is, stay the path with SLOs, except you need to be able to now start investing in what we kind of call reliability engineering or resilience engineering, which is basically how do we let our system fail gracefully, right? So when we do hit one of these thresholds, whether it's a quota issue or CPU capping out or some other form of, plateau, how do we let our system not completely collapse when that happens? Because that's really like the higher level concept that you're kind of referring to here is when something funny happens and we didn't have a leading indicator that we were tracking, how do we make sure the whole system doesn't collapse? Or how do we make sure we don't, even have a pretty big outage due to it or have some badness? The ideal scenario is something unexpected happens, so you hit some, either it's a quota or it's a scaling limitation that you didn't even know you had in your system. And you had no indicator for it, but you hit it because, you're doing great in your business and you have a lot of customers and you're making a lot of money. And one day you hit some number. Ideally, what happens is graceful degradation happens. 99% of users still continue to, send you checks every, second or whatever it is, make you money. But like some small number of users can't. And then you can notice that because it's showing up in your error budget. And then you can find the scaling limit and adjust it in due course without it being a complete panic, right? That would be ideal. But I think the path forward to that is really the way to get there is by, essentially, sadly, it's by finding those like the hard way a few times and having postmortems and saying, oh, we keep following the same pattern. We keep, having a bunch of client retries. Maybe we should introduce, exponential back off with jitter, and that will prevent this type of failure. Or maybe we need to have our load balancer send excess traffic to dev null, right? That way we can keep sending real traffic to the backend systems and not completely, crash the entire system. So essentially what I'm getting at is like, it's hard and I understand that, but like the answer isn't monitor more things. It's, understand the system better and keep monitoring, the end user's perspective, but find a way to allow your system to adapt, which is not easy, but it is possible. This is exactly resilience engineering.
So I just to making some notes here, but if we come back to if I hear this correctly, if I can kind of repeat what the perfect system should be, or what a system can be that makes this all possible, is we obviously start with our SLOs. And once we have problems, we use the cost tree analysis to figure out, okay, what's the real root cause, because we get faster with it. And then if we detect, hey, the last 3 times we had this outage or slowness, it was always the 90% full disk on this particular machine, or it was always the connection pool on this particular one. Then this obviously is new knowledge. We'll convert it into a leading indicator and say, hey, we've observed that once this indicator crosses a certain threshold, 10 minutes later, there will be a problem. So let's include this as not an SLO, but as a leading indicator for pre-alerting or for preventive alerting.
I actually wouldn't go that direction. Yeah. I would say instead, how do we make this thing, which is currently a leading indicator to outage, how do we prevent this from causing an outage?
Yeah.
How do we, I wouldn't say let's alert, because the point of an alert is to have a human do something or have a piece of code do some sort of mitigative step, right? Perform some change. Why not have the system just do that change? And if you look at the big picture of the system, maybe this is what you're describing, is that you just want the system to sort of like do its own sort of maintenance, I guess. But describing that as an alert can be taken the wrong way by some operational teams, and that what they'll do is they'll assign a ticket to an on-call human, right, and expect them. The phrase we use inside Google, which is kind of silly, is this is called feeding the machine human blood. You don't want to do that. You don't want to make sure that the systems persists or subsists entirely on human effort. In fact, you want to do as little of that as possible. So anytime that you say, let's add an alert, you should pinch yourself or something like that.
That's a good.
If instead you say, like, let's have a mitigation, that's fine. Like, so having a cloud function or something like that, or like a Lambda that like steps in and performs some mitigative action, that's a good mitigation. But again, like what you said before, there should be an expiry on that. That should give you time. That should give you 2 weeks to solve what the actual problem is. And if the actual problem is every time we run out of disk, then, we're unable to write the buffer out. The real solution is stop writing the buffer to a single disk. The real solution is start writing to a distributed disk abstraction of some kind, which has like an auto scaling backend and has, or maybe, change the disk that it's writing to have like a cleanup function. So that way, we always have plenty of space. And like these are all preventions. They're not, mitigations.
So, but that's,
this again goes back to the postmortem issue of how do you take a problem that happened in production, even a kind of not a big deal, like not a real outage, but like an almost outage. How do you get the monitoring? How do we get the prevention? How do we get the mitigation figured out?
Perfect. So I think
they're all related.
Yeah. But thanks for challenging me on that thought, because I think again, I'm taking notes here. I think
it's just my opinion.
I need to put on, I need to forward this list to the product team here, because I really like the thing that you just said. The number of alerts is a reverse indicator to your maturity. Or I'm not sure if reverse is the right, but it basically is not a good indicator if that grows. However, obviously alerts might be necessary for a certain period of time in case you have not yet found the right solution, long-term solution to a fix. So you can define an alert on a leading indicator, but it should have an expiry date, because otherwise they're lingering around and then you're just freaking out certain people because more and more alerts are coming in. And it's also not manageable anymore. Yeah. So that's why this makes a lot of sense.
Yep.
And you know what I really love about that last example, just goes to show you the level of, or the lack of maturity in my thought process on this, I guess, is, a lot of times when I see what we would call maybe a performance anti-pattern, my initial suggestion is, well, you should stop doing that then, right? But in your example with the, don't change your code so it doesn't do that. So you're not filling up the disk. Why are you filling up the disk? Well, there's probably reasons why you need to do something to disk. And I like the idea of just thinking, don't think of the solution as stopping the behavior that you're doing, because it might be a required behavior. Think of the solution outside of, well, you're writing to a single disk, write to distributed, like taking it to, there are new options out there, especially in the cloud providers. Like there's always another way you can mitigate that problem. So it's not necessarily that there's a problem with the code or the problem with the way the thing is operating. It's the problem is with the way it's just being handled, or the system that it's running on, and that can be improved. Yeah.
Another good way of thinking about this, the same problem, is that really what you want to do is just think about what kind of trade-offs you're making, and maybe you need to just make different trade-offs. For example, with the same example, this actually comes from a colleague of mine, Yaniv Aknin. He gave a talk at SRECon a couple years ago, I think, called the SRE I Aspire to Be. Actually, maybe it was 1 year ago, at SRECon Europe, I think. And he basically said, do you remember there's this little thing called RAID that we all know about? Basically, whenever we would write to a disk, it was fine until it wasn't. There was occasionally a problem where the whole disk just died. And so how did we solve it? We added a second disk. Oh boy, or maybe 4 disks or something like that. And so what we're doing here is we're still writing to the disk. We're not really changing the code that says, like, I need to open a file and write to a file and everything, but we're changing the system underneath. And what we're really doing is we're trading off reliability for something. And in the base case, you're just adding an extra disk, and really you're just paying twice as much for your disk. So you're trading off dollars or euros for reliability, which is a great trade-off. Like, we didn't even know that was an option before. And then, RAID showed up and said, well, if you just spend twice as much on your disks and put them together in this particular way, you never have that type of failure ever again. And then, everyone with a checkbook says, no problem. Like, let's do it. Like, this is totally worth the trade-off. So finding more trade-offs like that, where you're saying, I want more reliability and I'm happy to pay with either money or time or, compute time, compute process cost essentially. Finding those trade-offs is really where reliability engineering lives. And I highly recommend looking up that talk. If you can put it in the show notes or something, I'll send you the link. It's
I
really
just
good.
found it, so it's easy when we Google it. The SRE I aspire to be. We should add it to it. Yeah, SRECon 19.
There you go, 19. Oh, so it was a couple years ago.
Oh, last year, 19. So SRECon 19. I think that was, as far as I remember. If I look at my,
geez, it's only 2020.
It's still 20.
That's only less than. Oh man,
I know we all.
Nobody knows what day
time
it is.
travels differently.
We
now.
all want to forget 2020 because of the whole thing that is going on, but it's still 2020.
Yeah, we're past it, right?
Yeah, nope. It's funny, this whole so much of this conversation, I was saying earlier that I was thinking of a lot of songs when Andy was talking, and so much of the conversation about, people just did things to do them because that's the way they did that. It's come up a lot, and I just have to mention it keeps making me think of the Monty Python sketch, the operation room where the guy's like, bring me the machine that goes ping, and they wheel in this machine and it goes ping. He's like, there, it made the ping noise, because you're doing what you've been told to do and you've historically done, and you're not doing anything different, just marching on with the same old way, which we know is path to failure.
Yeah, that's cargo culting, right?
A little dramatic there. Yeah. What is that, cargo culting?
Oh yeah, have you guys heard of this? This is a great little silly story, which is the idea that during World War II there were like Pacific Island tribes that were basically invaded by this war showed up on their doorstep.
Yeah,
and so all these planes started landing on these islands and setting up sort of like refueling stations. And so they'd set up an airstrip, and like they would come in with all these planes with all this stuff in them, and the people who were like indigenous would. They'd kind of benefit, like they would give them food and stuff. And then all of a sudden the war was over and these planes stopped showing up, but the airstrips were still there. So the indigenous people didn't really understand what the war was or what planes were or anything. And so they said, well, if we make these control towers and we like put our arms up like this and we move our arms back and forth like the people did before, the planes will show up. And so then this is what they would do. And there's these pictures of these people who had built like control towers, small control towers, but control towers out of like essentially like wood and, sticks and stuff sitting on them. And they have like, they look like air traffic controllers, and they're trying to get planes to show up because they want, the planes to come back with like tons of food and people and supplies. And this was they called this the cargo cult because they wanted these cargo planes to show up, and they were just trying to sort of redo the actions that drew them before without really understanding what was happening underneath. So, it's actually, I'm not even sure how true the story really is, but like it lends itself to this concept of often, like I hate to say it, but often the operation, centers within these enterprises are filled with teams who are not well informed, and they're not well paid, and they're not experts at the systems they're operating. So they just do, like I said, like best intentions. They do what they've seen works. But at the end of the day, like often the entire system has been entirely changed under their feet and no one told them. And so they do something which is, basically the wrong solution because they don't know any better, right? No one told them to, we don't even use that database anymore. Like, why are you spending all this time making sure that its RAM is high or something like that? So, this is a really common pattern, which is totally preventable. And this is part of the problem of like, cause-based thinking, as well as, throwing code over the wall. Like these are all bad practices that lead to this kind of unfortunate position that some of our colleagues are in, where they're just desperately trying to keep the lights on by, throwing RAM at whatever server, has a red dot next to it on the monitoring system, which is, no good. The real solution is to have the people who understand the system be able to interrogate the system, to be able to make changes directly to the system that they wrote, and make improvements directly. That works much better. And it's a lot more rewarding, frankly, as well. So,
and don't forget, the key is to change everyone's title to include the word DevOps.
Please don't persist that. We know that's a bad idea. Like, I don't even want to put that out as a joke, right? Please do not rename your NOC the SRE team or the DevOps team. Like, this is a bad plan. All of you managers out there, this is not a good idea. So,
all right. Hey, it's amazing. We've been, I think, talking almost an hour, and Steve, the way we typically do this, and Brian, I know you probably wonder, what is he doing today? Is he doing the summary or not?
Do it now.
Yeah, no, I think so. Let me summarize quickly, because Steve, at the end, I always try to summarize what I learned today in a short fashion.
Okay.
Hopefully, I got it right. Otherwise, you can scold me later on or correct me. But I really liked, in the beginning when you told your story about how important it is to start with a post-mortem culture, and you have to make it easy for people to fill it in. It shouldn't be a burden or felt like a burden, but make sure people can figure out and write down how to detect the problem, how to resolve it, how to prevent it, and how to mitigate it, and then have kind of a culture around it to constantly review it and then learn from it. I think another thing I learned is that what thing that Brian and I have also been talking about in the past, the importance of monitoring is part of your code. So because in the end, we need to make sure that everything we do can be monitored. So it should not just be a siloed exercise where somebody else may or may not provide some monitoring data. So it should be part of the package you deliver. Now, the other thing that I really liked from you is coming to the cost tree analysis. So instead of looking and defining many, many different alerts and many different metrics we may think are good indicators for problems, start at the top, start at your SLOs, and they are typically close to the end user. And in case there is a problem, then follow the follow the path of figuring out where is the true problem coming from by following your distributed tracing tree or whatever monitoring tool you have in place, your observability platform that can then get you to the root cause. And I also like the definition of what reliability engineering in the end really is. It's really about how can we learn from these things and how can we make the system fail gracefully in case there is a true problem. How can we mitigate problems so we have more time to fix it for good? But I think that's what I like. So reliability engineering for me, what I took kind of notes. How can we help and build a system that fails gracefully in uncertain or unknown conditions and not fully crash? And that's also very important. Last thing, this is really what I'm going to take back to the product team on our end. While custom alerts on certain metrics might be a good idea for a short period of time, it's in the end a bad indicator for your maturity, because in the end, custom alerts just tell you that you are having a system and you're not actually investing in it becoming more reliable and more resilient, but you're still fighting more fires in the end because you get a lot of alerts. And really. So did I get it kind of right?
Yeah, I think so. One small point I would add is when you talk about SLOs being customer and user facing, that's totally accurate. However, as you become more mature, you're going to have many layers, right? And then some people say, or they ask the question, like, what if I have many layers? Do I have to have SLOs at every layer, or how does this work? And what if I'm a back-end team? I don't have customers, front-end customers. Your customer can be someone who works at your company. So if you're in charge of like the, document indexing service or something like that, your customer is all of the front ends who call you. They don't need to know what your SLOs are and how you're tracking your own service. It's up to you. So when I say, customer facing, sometimes that means internal customers. So that's just a minor caveat, especially like for business systems as well. Like if you have an entirely internal facing system for, big data analysis for your marketing team or something like that, then they're your customers. The marketing team is your customers.
Well, I guess that's also why they call them SLOs, service level objectives, and not site reliability objectives, because this is also a thing I want to make. Why do we call it SRE? Why do we call it site reliability engineering and not service reliability engineering?
The intent is that you're looking at the holistic giant system, right? It's calling it systems reliability engineering is a little, dated feeling. And then service reliability engineering is a little bit too specific. Like it's a little too focused onto one service potentially. Also, it's just a historical artifact. So it's the site. So Google was referred to as the site. So all of Google, whether it's Gmail or search or ads or cloud, this was all, the site that we're trying to make more reliable. I think it's just history.
Awesome.
Well, Brian, anything else from your end?
No, I'm good. This was excellent, Steve. I really appreciate you taking the time to come on with us.
Sure thing. It was really fun.
We've been having a lot of fun SRE conversations lately, and this one was all kind of a new direction. So it was really fun for our side. Glad you were able to do it all successfully from the car.
Sorry if there was background little pings as I was, people would drive by me and stuff. So I hope there wasn't too much background noise.
No, everything was great. Is there any final thoughts you want to add before we sign off, or you got everything?
I think one thing that's just worth noting is you can't buy SRE off the shelf. You can barely hire them. It's really something you have to build over time. It's specific to your company and your team. It's an investment. You have to take it slowly. You have to build it up. And one of the most important things you can do is you have to have it what we call an executive sponsor. Someone has to say, yes, as a company, we're going to do this. We're going to staff it. We're not going to cancel it in 1 year. It's not a project that has a timeline. It's not going to be done in 16 months. It is just a new job role that will be there forever. So as long as you take it that way, you will make continuous improvements. Your systems will become more reliable and you'll be more profitable business if that's your goal.
All right. Appreciate it. And what do you do, like LinkedIn, Twitter, anything like that if people want to follow you?
I'm Steve McGhee on all the things, STEVEMCGHEE on the Twitters and LinkedIn and GitHub and probably all the stuff.
Google Plus,
Wave, all of them. Yep. I think I'm pretty sure Google Reader had a username functionality and I had Steve McGhee on that too, but RIP. Or went out for Reader.
I heard that one was popular. I never played with that one. Anyway, thank you very much for being on the show. If anybody has any questions, comments, you can, reach out to Steve, obviously, or just follow him. If you have any questions, comments for us, you can get us at pure_DT on Twitter, or send us an old-fashioned email at pureperformance@dynatrace.com. I think that's it, right, Andy? It's been a while. Anyway, thanks for listening, everybody. And thank you, Steve, for being on again. Talk to you all soon.
Bye.
Thanks for having me.
Bye.